So I'm trying to figure out what the sequence is here. Has anyone figured it out? Yes. What is it? So it's subtracting by 2.5. Subtracting by 2.5. So minus 2.5, minus 2.5, minus 2.5. So the common difference is negative 2.5. But I want to find the 10th term. I could keep going, minus 2.5, minus 2.5, minus 2.5. I could do that. But what if it asks for the 100th term? I'm not going to do that. Okay, so you learned last class the explicit notation formula. Bless you. Last class you learned the explicit notation formula, which is here, down here is how we find any term in the sequence. This is how we find any term in our sequence. So A1 represents the first term in the sequence. So what is the first term? 2. The common difference, the D, is negative 2.5, so minus 2.5. And which term are we looking for? The 10th term. So I'm going to plug in 10 for N. So to find the 10th term, I need to solve this. Well, just put this in the calculator. 2 minus 2.5 times 10 minus 1. Put it in the calculator. Do it. Do it. Oh, you have the answer? Everyone else who's just sitting there looking in La La Land, do it. Stop waiting for other people to do it for you. Let's go. All right, Jaden, what'd you get? Negative 20. Yes, so the 10th term would be negative 20.5. Okay, so today what are we learning about? Geometric sequences. Geometric sequences. Okay, last class we learned about arithmetic sequences, where you are adding or subtracting by the same thing. Geometric sequences is when you're multiplying by the same thing. So if I was writing notes, I would write geometric sequence. Is when I'm multiplying by the same thing. So let's look at an example. 3, 6, 12, 24. 3, 6, 12, 24. I know I'm not adding by the same thing because 3 plus 3 would give me 6, but 6 plus 3 would not give me 12. So I know I'm not adding by the same thing. Other than Alexa, what am I multiplying by? 2 times 2. So I'm multiplying by 2 every time to get to the next term in the sequence. So here, instead of saying the common difference, we use the word common ratio. The common ratio here is 2. So R equals 2. The common ratio equals 2. And how would I find the next term in the sequence? Perfect, 24 times 2, which will give me 48. So the next term in my sequence is 48. So you should clearly see the difference from last class. Last class we learned about adding or subtracting by the same thing. This class we're multiplying by the same thing. So that's the difference between. Great question. It's just multiplying. And if it's getting smaller, then you're like, well, then it's dividing, but it's just multiplying by a fraction at that point. It's multiplying by a number less than 1 if it's getting smaller. For this example, this is a good example. 4, 2, 1.5. Multiplying by 1/2. There you go. So here I'm multiplying by 1/2, multiplying by 1/2, multiplying by 1/2. So my common ratio here is 1/2.
And none of these ones will be divided.
No. So you're always trying to figure out what you're multiplying by. Hopefully you may not be making the connection, but this is exactly what we did a couple weeks ago with exponentials. When we had a table, and we were trying to figure out, well, what's the equation of the table? Oh, my first term in the sequence was 4, so that's my A value. And what am I multiplying by every time? Oh, 1/2, and that was my B value. So this is the same exact thing. I didn't mean to put a here. This is the same exact thing as an exponential equation. Same exact thing. Same exact thing. Same exact thing. Okay, so what would the next term in the sequence be? 0.25. Okay, so we're gonna learn the two different things as we did last class. So the first one was recursive notation. Remember, so if I'm writing notes right now, I would write recursive notation. We use this to find the next term in the sequence. We use recursive notation to find the next term in the sequence. We use recursive notation to find the next term in the sequence. And the formula is AN equals R times AN minus 1. That looks complicated, but all it's telling you is whatever term you're finding, you would multiply it by the common ratio times the term before it. So let's say I had this sequence right here. Just kidding. What's the common ratio? 3. I'm multiplying by 3 every time. Multiplying by 3 every time. So let's say I want to find the 5th term in my sequence. Okay. If I want to find 27 times 3. So So yes, ma'am. Can you wait like 5 minutes? Okay.
I got it.
So yeah, so I don't want the answer. I just want to write the equation. So if I was looking for the 5th term in the sequence, it would be A5 equals, well, the common ratio was multiplying by 3 times AN minus 1. Well, N 5 minus 1, A5 equals 3 times A4. Well, this means the 4th term in the sequence. What was the 4th term in the sequence? 27. So A5 equals 3 times 27, which would give me what A5 is. I don't know. What's 27 times 3?
I didn't know what it.
Why'd you do times 6?
So you can get the last one, the 5th one.
No. Oh, you were
the 6th one.
Yeah, you did the 6th one.
88.
88? No, 81. 81. That's what you said, right?
I'm going on a big number.
Okay. Okay. So this is just saying multiply the common ratio by the number before, which makes sense. That's how I would find the next term in the sequence.
Could you go back, Ms. Patterson?
Yes.
So where did the A go?
So remember, A represents the number, and the number. So A4 is, what is the 4th term? Well, the 4th term was 27. So I'm taking A4 away and putting 27. So that's just saying what is the number what is the number on the 4th for the 4th term? Good question. So I hope you wrote this formula down. I'm going to ask you for it in a minute. Jada, am I good?
Oh, yeah.
So R stands for the common ratio. AN minus 1 represents the term before. So look at this sequence right here. 3, 12, 48. Everyone in your head, go ahead and figure out what that ratio is. Don't say it out loud. Everyone in your head, go ahead and figure out what that ratio is. All right, someone who hasn't answered. And you've answered, Noah. You've answered, Alexa. Sophia, what is it multiplying by? 4. So it's bless you. It's multiplying by 4. So I want everyone to write the recursive formula if I wanted to find the 4th term in the sequence. Here's the formula. Write it if you want to find the 4th term in the sequence. Okay, Leo, say it out loud.
So A4 equals 4, and then parentheses.
Perfect. Okay, I'll write my A's differently. A4 equals 4 times A3. And what's the 3rd term in the sequence? 48. So I'm going to replace that with 48. So 4 times 48 will give me my 4th term in the sequence. Oh, look at you. Yeah, 192. Yeah, so the 4th term in sequence would be 192. Does it? So the question is, you're not going to memorize this formula. Let's just be real. It's not going to be on your formula chart. You're not going to memorize it. But you don't need to. You got to think about it. It's just telling you to multiply the term before times what the ratio is to get to the next term. So it's more like common sense. It's not something you have to memorize. It's okay to figure out the next term. I just multiply it by whatever it was multiplying by. So there's no need to memorize a formula. It's more like, well, how would I get to the next term? I would multiply it to get to the next term.
Miss, it won't ask for like the 8th term or something like that? It won't be asking for like the 10th term?
Oh, such a good question, Rodolfo, because that's the next thing. Explicit notation. Let's just say explicit notation. Explicit notation is to find any term in the sequence. So we use explicit notation to find any term in the sequence. Huh? I don't think so. Okay, we're explicit notation. So if I'm writing notes, I would write explicit notation is to write any term in the sequence to find any term in the sequence. So just like Rodolfo just asked, well, what if I was asking for the 8th term, the 10th term, the 1000th term? I would not keep multiplying.
Well, like you just, it's like common sense. Like, okay, so like 3, you just keep going 6 and 12, or like 9 and 12 and 15.
Well, that would be if it was adding by 3. But what if you're multiplying by 3?
Yeah.
Miss, but we're just gonna have the calculator, so you just keep on pressing times 4.
Yeah.
But so what if you ask for the 900th term? You're gonna do it 900 times?
Yes, Miss.
Okay, well look at this formula. AN equals A1 times R times to the power of N minus 1. Well, if you go, I'm gonna go back to this. If you go back to the beginning where I said this is, look at this. What does this look like? The same exact thing for an exponential. So this is an exponential equation. AN equals A1 times R to the power of N minus 1. This is what we just learned last week, which I know some of you don't remember. This is what we just learned last week. This is the same exact thing. So A1 represents the first term in the sequence. R represents the ratio, what I'm multiplying by each time, to the power of n minus 1, whatever thing I'm looking for, minus 1. And the reason it's doing n minus 1 is because it's not giving you the actual y-intercept. It's just giving you the first term in the sequence. So this is subtracting the fact that we don't have the actual y-intercept. Do we have it written down?
Yes.
Well, at least some of you who are taking notes. So here, 3, 12, 48. This is the same one we just did a minute ago. I'm multiplying times 4. Well, write the explicit formula. Everyone write it down if I was looking for the 9th term in the sequence. Write down the formula if I was looking for the 9th term in the sequence. All right, no, go ahead.
I just got the number, the 9th term.
No, I don't want the 9th term. I want the formula.
Bruh.
No, if you don't know it, then that's fine.
I just went to the 9th term.
I can give you the equation.
Yeah, wait, can you have to do one more explanation and I'll do it?
No,
Then
no.
I can do it again.
Yes, but so the thing is, any question I've seen on the EOC usually is asking about the formula. It's not asking for like an actual term sometimes. I'll go look up some questions, but sometimes it's asking for the formula, sometimes it's asking for the term. So that's why you need to understand both of them. So does anyone, other than Leo, does anyone feel like they can write the equation for me for the 9th term?
Wait, I think I can.
Here, let Alexa do the first one. You can do that. Go ahead, Alexa.
Oh,
Well, what is A1? A1, the first term in the sequence is what?
Oh, it's 3.
3. Uh-huh. Uh-huh. Perfect. Okay. So here, the first term in the sequence was 3. So that was A1. 4 is the common ratio, what I'm multiplying by, to the power of 9 minus 1, which she said is 8. So A9 would equal 3 times 4 to the power of 8, which I definitely do not know that.
Oh, it's 1,900. Sorry. 1,728.
Were you just multiplying by 4 each time?
No, I just multiplied 9 times 4. Got that, and then multiplied 48 times. Or I think it was 36.
So this number is actually 196,608.
What? Wait.
That's the 9th term in the sequence. Because this is exponential, so it's going up quickly.
So, what times what times what?
Right here.
How did you get 608?
Times 4 to the power of 8. Huh?
So you put the power of 8 to 4?
Yes.
Oh, I didn't know you gotta do the power.
So that's why. So this is why I was saying, like, don't try to be like, oh, let me just keep multiplying by 4 or whatever. Actually, use the formula, okay, to get the correct answer.
Hold on, man. How much right?
If I'm in my calculator and I was doing that 3 times 4 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 times 1, 2, 3, 4, 5, 6, 7, 8, 9 times 4. Yeah, I'm not even getting the right answer. So hold on. 3 times 4 to the power of 8. So 3 times 4. 1, 2, 3, 4,
Yeah,
5,
right.
6, 7, 8, 9.
I must have did something wrong.
1, 2, 3, 4, 5, 6, 7, 8.
I got the right answer, miss.
Yes. Okay. Last slide. So what I want you to do on this slide is exactly what it says. figure out what it's multiplying by. I want you to write the explicit formula, the recursive formula, yeah, in the 19th term. You're welcome. Okay, so go ahead. I want you to take 3 minutes and then I'll call on a random person.
What?
So I wrote for you what the each equation is. Now I want you to write.
Just the formulas.
I know how to
I want you
do
to write the formulas and go ahead and find the 19th term without multiplying it the 19th time.
It's easy. It's like sort of easy.
Mm-hmm.
Yes, it is. Yes, it is. It's simply-
Mm-hmm. It's gonna be a decimal. It's gonna probably be a very long decimal too.
1.5.
Yeah, because whenever I'm doing it, it's gonna give it puts it in scientific notation for me. Okay.
Wait, don't go.
This is a little.
Oh, God.
That's a word.
Liz, did you get, does it start with the 5 3?
Mm-mm. Okay. So the people in the chat or the person in the chat is asking about what is it going by. So if it's going down, so you know whatever you're multiplying by is gonna be a decimal, something less than 1. So think 4 times what will give me 2. 2 times what will give me 1. 1 times what will give me 0.5.
Exponent
Yes.
18,
That's what I put. What'd you put in the parentheses?
1/2,
What'd you put on the other side?
4.
I put that.
Did you put A and then 19 and then, below it and then equals all that?
What? Oh, okay.
No, we did this.
Okay. Jaden, can you give me the explicit formula?
Yes. So I put A19 equals 4 parentheses 0.5 and then 19 minus 1.
Perfect. Okay. Someone else give me the recursive formula. Not. Yes. Okay. Go ahead and give me the recursive formula.
A equals A19.
Okay.
Equals 4. Or no.
R stands for the common ratio, so it's multiplying by.
Oh,
Mm-hmm. Okay, and then A, if you're looking for the 19th term, 19 minus 1, which would be 18. So if I reduced all of these, A19 would equal 4 times 0.5 to the power of 18. And if I was using recursive formula, A19 equals 0.5 times A18. But we don't have the 18th term, so we couldn't even use this formula. So the 19th term, when I got it, I got 0.000015 something. Is that what y'all got?
yeah.
Okay.
What is that?
Well, does yours say 1.5 blah 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 e -5? That means that's scientific notation times 10 to the power -5. So you move your decimal 4 places to the left. This is from that's from last year. Yeah. All right. So